This is the hardest part of the chapter. I keep saying that every section. But
I lost it at the derivatives. I'm not going to lie.
okay, I'm going to go back.
Oh.
Do you agree that you put the 1/2 in front and you drop the exponent?
Yeah, I have that.
And then do you have this? The derivative of u is that? Do you follow me there?
That's where I'm stopped at.
Okay,
So
now
you
we put it.
the other stuff in for you.
Yeah, we put u back in and simplified this and then took it times that. And that is the first of that slide right there.
All right, I got it.
Yes, dear.
Can you explain why you have to multiply by x? Like I know
Okay.
you said that, but I just don't know why you would do this.
Before we were always doing the derivative of x and it was always in relation to y when we were doing the derivative. Now we are doing derivatives in word problems, and in this word problem we did the derivative of x with respect to time instead of with respect to our y value or our distance value. Yes. So the derivative of d is with respect to time, and this one is with respect to time because in the given, they give us that dx dt. That's why. And in all of our previous problems, everything was with respect to x, dy over dx. There wasn't a third variable in there, where now we have that third variable of time.
Okay. So how do you know which one?
If it's a word problem, put prime on everything that you do. Take everything times the derivative.
Okay, how do you
Where
know,
is-
like, since you have three variables now, how do you know which one to multiply? Is it always going to be x prime? Or like-
Yeah, whatever letter you were using. So we were using x here,
Yeah.
so that's why it's x prime.
Okay.
Here we were using d, so that's why it's d prime. If we had t in it, then it would be t prime.
Okay.
Yes, dear.
So you just add that back in when you're like,
Your final answer, yes. Gabe,
You go back to the other one. Where'd that 2 come from?
this one,
Oh,
Came-
no, the other one. Right there.
that one,
No. Yeah.
from the half, we rewrote this as 1 over 2 times that to the half, and we put this on top. Sometimes you guys write it like this, because you don't want to put that on top.
Oh. And then after that, you just plug in 2. Is that what they said?
Yes. So some of you like to write it like that, where you don't have it on top. And you can do that. That's fine. We should put centimeters per second, yes, for our distance, but as a label. Kind of crazy, huh? But since we don't actually have a point, that's why we aren't getting a numerical value, because it's... Shall we try another one? Okay. Try number 14. Try number 14. I assume you can do it, but some people might not be able to. Now it's working. Would you guys like me to start or wait? You want me? Are you ready for the derivative? Okay. Are you guys good up to the d equals part? Are there questions on the d equals part? Okay, so derivative of d is 1/2 u to the negative half. So we got 1 over 2, and our u is x squared plus sine squared x to the half. Alright, so now u is x squared plus sine squared x. So what's the derivative of x squared?
Doesn't matter where you put the square.
No. So derivative of x squared is 2x. What's the derivative of sine squared? Can you do it? You have to go to w. So, I am going to go to w down here. Alright, so we got x squared plus sine squared x is what we're working with. We're going to call this w squared. So w is sine of x. What's the derivative of w squared? What's the derivative of sine x? Well, that didn't work very well.
Wait, so we're gonna be able to see the board on the internet?
Hopefully. You don't think it will? Is it not working? Oh.
Maybe.
You just have to go just around this one spot on the
Yeah, you can see it.
Okay, so we got 2w. So let's put it back together. So we got 2 times sine of x times the derivative of w, which is cosine x. So we got 2x plus that jazz. 2 sine x cosine x. Correct? So here was my derivative, and I need to take it times u prime, correct? Do you agree?
Yes.
So I'm going to put that on top. 2x plus 2 sine x cosine x.
How do you get the sine x cosine x?
That's where we did w. This we wrote as w squared.
So you have to put, when you go back,
When you put it back together, the derivative of w is only multiplied times that part.